Hi there, so this is your astronomer from Helsinki, and I'm talking today about some different technical terms when working with IRAF data reduction for spectroscopy. So I'm gonna share this window. Let's see, too many windows, but basically I'm working on this project Rainbows, and some questions came up which prompted me to dive deeper into some of the documentation um, um, technical vocabulary, and I wanted to share with you. Also, maybe you have the same questions. They say in science, if you have a question, somebody in the audience also has the same questions. They're just also afraid to say it. But anyway, I do mark in my research notes if I have a question. And actually, I had a problem because so first things first, I'm working on this project Rainbow's Open Science video tutorial, and I did wavelength calibration, and something looked fishy to me, so I decided to study my wavelength calibration and go over the records just to make sure everything is right. Yeah, so the wavelength calibration uses these 4 steps, 4 tasks with IRAF, and I am using a 2D image to wavelengths calibrate on a 2D image. And these task names are identify, re-identify, feed coords, and transform. But so the first warning is when you are in IRAF environment, you really need to make sure that you are using the identify, re-identify, feed coords, and transform from the 2D spec package. If you are working on a 2D spec, I don't know what happens if you don't. So this is the NOAO 2D spec long slit. Actually, in this case, it's long slit, and then you can find identify, re-identify, feed coords, and transform. Here's the feed coords, because you have to be careful you're not in a 1D spec environment, which is also from the NOAO 1D spec environment, because it also has identify. Well, let's open the identify there. Re-identify, it has the same names for the tasks. Feed coords, I don't know, maybe it doesn't need for feed coords because of the, it's not doing that step there, but it does have identify. So let's see. So you might have to make sure that you are doing it correctly and you are in a correct environment. So maybe if you are, it will give you an error once you get to the feed coords, because it doesn't have feed coords here in a 1D spec. So that's number one. You check to make sure if you already extracted a 1D spectrum, then go ahead and use 1D spec for wavelength calibration. But if you haven't extracted it and you're still in a 2D image, which is what I am doing, because I'm working with extended faint galaxies and I'm trying to preserve the signal, I use 2D images, so I use a 2D spec routine of identify, re-identify, feed coords, and transform. So I think IRAF sometimes is forgiving in that if you make a mistake, it doesn't matter, like fixes it, but I don't know, I didn't test it. That's just one thing to keep in mind. And then now, when you work with identify or any of those, what's happening, and we talked about it, where is it? Do I have a picture? It's a coordinate problem, coordinate and unit problem. Just give me 1 second to find my And I'm not really monitoring the chat. I hope nobody shows up. I'm just using it to record a longer video, using the live stream to record a longer video because it lets me just upload it and I don't have to save it on my computer because I don't have space for large video files, which take a lot of space. It comes with catch. Sometimes it okay. Did I not save it? It's okay, but I saved it on TikTok. No, let's go in a different window so it doesn't ban me, because it shows automatically somebody else. Okay, so just one more second, please be patient. Where's my function? Here it is. Okay. All right. So it says, okay, let me share window. I see what I did wrong. So this is my project, and this is the the NIO to this spec. It's commands such as identify, but there is the same identify, a command with the same name, a task with the same name under one spec package right here. Okay, I'm not really monitoring, so the chat. So let's go back to this spec. That's what I'm doing. And then the long sleeve package. So this is to this spec long sleeve package identify. So this is very technical vocabulary. I would say it could be improved to make it more user-friendly, but a lot of the people have engineering mindset who write this, so they don't have good skills to make things to make the user experience well designed and well, because that's not their strong suit usually. So that's why I think my husband has a job, because it's important to take user experience considerations. And unfortunately, in astronomy, it's not taken into account as in other technical fields. So a lot of it's geared towards a certain type of way people process information, and is not diversified. So yeah, if the design took into account user experience for documentation, for example, for software tools, they would increase, I believe, participation of women, for example, because they would be able to present information in a way that is not just appealing to one type of way of processing information, but a diverse way of processing information. Basically, features, what it says here, features are interactively marked in one-dimensional image vectors. Yeah, even though it's in a 2D spec, what happens with identify, it actually internally creates a 1D spectrum. And I have to say, I was using ChatGPT to go to discuss this topic, the free version, so it stops after a certain number of lines. But even ChatGPT, you have to be careful because it makes mistakes. So it was making a lot of mistakes, partially because of the 1D spec, 2D spec, and also mistakes in terms of your orientations. The dispersion axis can be either horizontal or vertical, so it assumes things. I know where it gets its information, so you have to be careful. Yeah, ChatGPT really makes mistakes, but yeah. Anyway, I like using it because I want to learn to be AI literate and not AI illiterate. So I try to use it. My dad gave this advice to be tech literate, and I like this advice. to all his. He has 4 daughters, and he celebrated for us and encouraged and supported and gave resources to be tech literate. So that's something I want to impart to my children as well. So I don't ban cell phones, or I teach them how to use a computer, keyboard typing. Those are all good skills. So you don't have to do. You can know how to use it as a tool, not know that it is some sort of difficult things that you can never do, especially as a woman, any high-tech computers and stuff. And also, it's not the forbidden fruit that then you crave and go crazy on and play games for 7 nights straight. I don't know. So identify features. So actually, identify is one of those steps that internally, when you feed it an arc line, let's say we are first using an arc lamp frame to calibrate, and we are feeding this arc lamp exposure as an input into the identify. What it does, it actually, because it's a 2D frame, it takes out, maybe I can show you a frame. Let's see if I can find it. $65. So I'll have to share and then share. Maybe I'll just share the entire screen. No, because then it does back. So this is a 2D frame. It's not flatted or anything, but it's just a raw frame of an arc image, and it has all these lines. This is the blue region in the optical. This is a red region. In this case, it's a helium neon arc, and I did my observations with Nordic Optical Telescope. So this is how a helium neon arc lamp exposure looks like. It's a bunch of lines. Some of them are, these are emission lines. It has certain precise emission lines, and each line has a certain wavelengths. Right now it is not calibrated because it has, so it is represented in user units. And can you see my, yeah, you can see this. No, not in user units. What am I talking about? In pixel units. So this is a 2D frame, x-axis, horizontal axis, y-axis, vertical axis. And there are pixel 1 to 2000 something, pixel 1 to 2000 something. It's like a square, some kind of rectangle. So it is 2K by 2K approximately pixels here. So this line is on pixel 631, 1531. So as I go, I look here, the X and Y coordinates are given of the pixel here. But what the identified task does, it takes a slice, like from a middle column, it takes a slice, and maybe sums 10 columns, for example, together, or takes an average and creates a 1D spectrum. So it's not wavelengths calibrating the 2D image right away, actually it starts kind of with a 1D calibration. It does a 1D and internally extracts a 1D spectrum of this helium neon exposure from a middle column usually. So I'll go back to sharing. So, okay, let's do maybe window and I'll do like this. No. Okay. Okay, so this is my raw frame, and it internally takes out or extracts a 1D of this, so you will have some sort of let's see if I can find helium neon arc. Maybe it's just to show you. Ah, yeah, maybe it's better. Okay. So it does something like this. A 1D spectrum it extracts. In here it looks like it's a neon lamp, but we use the one helium neon because the neon lamp alone, which is here, doesn't have a lot of emission lines on this side. So that's why we combined two lamps in order to get emission lines also in the blue region. So it extracts a 1D. How does it do? What does it do then on this 1D? It you mark features, the user interactively one-dimensional image vectors. In one-dimensional image vectors. So this is what it is. One-dimensional image vector is basically the 1D spectrum because we're doing spectrum extraction. There are other cuts you can do, but you mark like when you do the extraction, these lines are not labeled. It's pixels here on the x-axis. And you manually mark this one through the identifier, or this one, and say you mark 3 to 10 lines with your with wavelengths from your reference file because they are known. And then, so this is what it means. The features may be spectral lines. That is when the vector is a spectrum. This is what it is. Our vector is a spectrum, and we are marking the spectral lines. And then a function may be fit to the user coordinates as a function of pixel coordinates. So I wanted to discuss these two terms as the last point. Pixel coordinates, it means your 1, 2, 3, 4, 5, 6 pixels. So just the position of the pixel, just the pixel position or pixel coordinate. And the user coordinate, in this case, are wavelengths. They are measured in angstroms. So you have to be careful because we are trying to get wavelength calibrations. Our goal is to get user coordinates. So we, with this process of identify, after we mark that, okay, this line is, I don't know, 3,000 angstroms, this one is 2,500 angstroms. I'm just saying numbers here, pretend numbers. Then maybe I mark here, this is 8,000 angstroms. After I mark them, identify task, identify also the rest of the lines. After I give it initial 3 to 10 lines manually, it then marks all of the other ones by itself based on your markings. And then it creates a fit. It basically fits with the function, which is I chose to be Chebyshev polynomial, and you can play with the order. I believe my order was 4 at the end. I wrote order 4. So you can play with the order and then see which one fits better. And then you get a map of what I talked about in this video on TikTok. You have your CCD pixel coordinates, the pixel position, and through that functions that you derive with the identify, you get your wavelengths coordinates, angstrom coordinates, or user coordinates. So this is what happens. Because in the beginning, you don't know 5, 5 in your spectrum, let's say in this position, pixel position, what is a wavelength? That's why you have to do the calibration. Just quickly glance at the chat, nobody's saying anything. And the very last thing, when I was doing my check to check myself, I was trying to understand because I saw that other people did different things. So I wanted to make sure I have understood correctly the parameters. So I went into the identify task and I made sure that I understand every single parameter just to make sure it's working correctly and I didn't make a mistake there. And one confusing one was this match. And this is in 2D spec long slit package versus the C radius. So the match is coordinate list matching limit, but it is explained a little bit more in the documentation. The maximum difference for a match between the feature coordinate function value and a coordinate in a coordinate list. The coordinate list IRAF comes with the helium neon arc coordinate list, meaning that it's a list of emission lines. For that helium neon lamp frame. So this is happening, this matching is happening when the user is marking the features and saying, okay, this line is this line is that. I guess I have nicer pictures here. So when I get my 1D spectrum of the helium neon arc, I by hand mark a few features. During that time, when I mark it, I put some value here. So at this point, it is match parameter has to be negative. There was a question, should it be negative or should it be positive? It's a matching between it's the difference for a match between feature coordinate function value and a coordinate in the coordinate list. It turned out not to be a big deal because IRAF will fix it if you put the negative or a positive value, but I spent some time understanding it. Well, you don't have coordinate function value. The coordinate function, this beautiful rainbow function or dispersion function, you don't have it yet at this point when you are just doing wavelength calibration. So it has to be negative because all you have is pixel units, pixel coordinates. You don't have user coordinates. In a different setting, you might have user coordinates if you already have this solution. But at this point, you don't. Okay, this is one. And then the C radius is also kind of a matching thing, but it's something a bit different. The maximum distance in pixels allowed between a feature position and the initial estimate when defining a new feature the maximum distance in pixels lie between a feature position and the initial estimate when defining a new feature. So a feature position is like a centroid radius. Is now happening. This is happening later when the program is identifying the feature. So this is match parameter of the identified task is happening at this stage when you are marking yourself. But the do I do anything? The C radius is then happens later when based on your when the program is identifying by itself all of the different peaks and the way it's all of the different emission lines, and the way it does identify an emission line is by marking its peak. So within that C radius, it's looking for a peak. So this is the C radius, and also in pixels, it's also what it means. And I asked ChatGPT, well, how to identify this centering radius? How do you identify this? And I think its answer was correct. Did I? I said I put it in here. You can approximate. You can estimate it based on how good is your data. So if you have good observations and very exact lines, or if your resolution is not so good, so it depends on that. So you can use, for example, full width half max measurement in order to guide yourself to identify initial case for C radius. And what you can, even if you don't have a wavelength calibrated frame, you can measure the base to base of an emission line, which in this case, it was 9 pixels. And from this, you can calculate the full width half maximum approximately, assuming it's a Gaussian, with that assumption. So what did my Gaussian become? It was 9 pixels. So base to base width is about 2 times full width half max. So full width half max is 9/2 is something like 10/2 is 5 pixels. And I was a bit generous. I gave 6. C radius 6. It's just an initial guess. And you can actually test it. You can go more conservatively and put like 3 pixels if you want, and test how it works, because if it's too strict, then you will not identify any lines, or you will miss a lot of lines, and that will be an indicator for you to go higher with the C radius. So this is the peak. And then if you give it too big, let's say you gave it 20, I don't know, or 100, then you will see that your identifications at the end are not so good, and some lines are misidentified. So you can go more conservatively. Okay. I think this was it, and I'll check. Now I'll stop sharing and end the stream. Thank you so much for your attention.